And there's three types of equations we're going to cover here. The first is a linear equation. And again, I'm just going to do a quick example of this. This should be something that you guys are very familiar with. There's one simple rule for this, and that is isolate the variable. Okay, when you're solving a linear equation, all you're looking to do is move all the terms that contain your variable on one side. It doesn't matter which side. You usually move it to the side that allows you to work with positive numbers if possible. Okay, so if we subtract a 3x from both sides, that gives us 4x on the right. In the same step, we can move all the constants over to the other side. So if we subtract a 9, and then what this allows you to do is combine, or I completely isolate the variable now by undoing that operation divided by 4. And so you get negative 17 over 4 as your solution. Okay. What if I gave you the following problem? I want you to see if you can solve this equation very quickly. Right. In this particular case, if you have grouping symbols, you need to remove those first. So distributing the negative, get a negative 1 and a positive 3x. And then if you were to combine all your like terms, 2x plus 3x, you're left with a 5x. Well, here when you subtract a 5x from both sides, you get 0 is equal to negative 1. Is this a true statement? No. Your calculator on this type of problem will tell you false, and all false means is there's no real solution. Okay, now what if you solved the problem and you wound up getting 0 is equal to 0? Your calculator in this case will tell you true, and what that means is all real numbers would work. So if you get a case that reduces down to 0 equals 0, now this also means like 5 equals 5, right? Because 5 equals 5, you can subtract a 5 from both sides and still wind up with 0 equals 0. If both sides of the equation are exactly the same, it's called an identity, and that means that it's true for all possible values. Okay, I want you to try this one. This would probably be kind of the upper limit of complexity for a linear equation. And so this is 2ax minus 6 equals bx plus 1. This is sample problem 1 on page 38. Right, if you're working to isolate the variable, again, you follow all the same steps. Put all the terms with your variable on one side. It doesn't matter which side. Here I'll move them to the left. So that leaves me with 2ax minus bx on the left. At the same time, I can move all the constants to the other side. So if I add a 6 to both sides, and set that equal to 7. And now, in order to isolate this variable, I need to get it out of these two terms. Now, if two terms share a factor, what can you do with that? Factor it out. Right? So if you take out this common factor of x, that leaves a 2a in the first group minus a b in the second group. And so all you need to do now is divide, undo that operation. So if we divide by 2a minus b, we get our solution of 7 over 2a minus b.